Hello, PreCalc. We are looking today at a new topic, and it's actually related to the last video you saw. You'll see the connection in a minute, and it is going to be observed on Tuesday at some time. That's January 5th, 2016. So, what we're going to look at today is a rectangular array of numbers, and you've had this before, I believe. If not, welcome to the study of matrices. So a rectangular array of numbers, is called a matrix. So let me show you what a matrix could look like. Let's say I put 2, 1, 5 in the first row, 3, 2, and a -6 in the second row, and I cut it off there. Every matrix has a size. We call it an order, and it's always the number of rows by, with the symbol X, the number of columns. And so this has 2 rows and 3 columns. So its order is a 2 by 3. So that's how we state that. All right. Now I'm going to take what we learned yesterday and turn it into a matrix. So say we had 3 equations. Remember, we're working in 3D space and finding the intersection point of 3 planes. And 2x minus 4z equals 6. Alright, so there's are the equations we're working with. Let's see if I can get them in the screen a little better. The lighting looks a little strange. X minus, that's a 4y plus 3z equals 5. Minus x plus 3y minus z equals -3. And 2x minus 4z equals 6. So again, we want the answer to be an ordered triplet with first the x value, comma, y value, comma, z, comma, z in parentheses. So we used to have ordered pairs when we had 2 equations and 2 unknowns. Now we have an ordered triplet. The matrix that is associated with this equation, this system of equations, looks like this. We're going to grab from the equations just the coefficients. So the first equation becomes this matrix, and there's the constant. So the second row is going to take on these constants and coefficients. And the third one is going to take on this, and this, 2, 0, -4, and 6. We put a little dotted line down this part of the matrix to separate the coefficients from the constants. This is called an augmented matrix. We will perform elementary row procedures, operations, I guess, and we will find the solution to this equation using the matrix. Here are the elementary row operations that are allowed. We can exchange any 2 rows. We can multiply any row by a constant as long as it's not 0. We can multiply a row by a constant and add that to another row, replacing that second or latter row. All right, very similar to what we did with equations last time. So let's go ahead and take this matrix and begin. I want to put it in row echelon form. So if you recall, this has to be a 1, and it already is. So this represents the coefficient of the equation over here. And you recall from yesterday, or sometime previous, we had to have a 1 here. And below this has to be zeros. So I'm going to take row 1 and add it to row 2, replacing row 2. Will that not cause, this has to be a 0, and that will cause that to be a 0. So let me perform that operation, giving you the result over here. Alright, so when I add row 1 and row 2, this row is going to be unchanged and this row is going to be unchanged. So I always write those in first so I don't forget what in the world I'm doing. I'm going to put in the last row. And all I need to put in now is the changed row. So I'm going to add these two and replace this row. 1 plus minus 1 gives me the 0 in this spot. -4 plus 3 gives me a -1. And a 3 and a -1 gives me a -2. A 5 and a -3 gives me a +2. Alright. Continuing on, the next step, similar to last time when we were using equations, is going to involve this number. Guess what I want it to be? Remember, the lead coefficient was 1 and everything below it was 0. So we want that to be a 0. So I'm going to look at that, and what I'm going to do to get a 0 out of this, I'm going to multiply the first row by a -2 and add it to the third. So -2 times row 1 plus row 3, replacing row 3. So I'm going to put in 1 and 2 unchanged. And now I'm going to multiply row 1 by -2 and add it to row 3, replacing row 3 with those new numbers. -2 times 1 is -2 plus 2. -2 times -4 is 8 plus 0. -2 times -3 is -6 plus a -4, -10. And -2 times a 5 is a -10 plus 6 is a 4. So those are the new numbers. And I will now take those and observe what has to be adjusted next. We already have a 1 in this row, so the lead number has to be a 1 and under it are zeros. And we get to here, this has to be a 1. So all I have to do to make that a 1 is multiply or divide. I'll say divide. Row 2 divided by -1, or row 2 divided by 1. Multiplied times 1. Same thing. So it'll create, I'm going to rewrite the first and the third row because they're not involved in any change. But the second row, I'm going to divide each thing by -1, each element, and I get a 1, a 2, and a -2 when I do that. So coming right along, we are going to see that, did I get that right? Divide, alright, 2 and a -2. I think I did that wrong on my paper. On my practice paper, it looks like I did that wrong. Maybe not. Let me check something. Up here, oh yes, up here I already had a mistake. You have two hands up? When I added these two rows, I should have gotten a +2 here. Glad I caught that. And then when I divided that +2 by a -1, this did become -2. So I'm glad I did this ahead of time. I could check against it, because one little mistake like that and you're all messed up at the end. Alright, can you foresee what value I will address next? The lead number in this row is 1, the lead number in this row is 1, and the lead number in this row, this is anything under a 1 has to be a 0. So I've got to make that into a 0. So the only way I can do that is multiply row 2, because there's a 1 there, I'm going to multiply it by -8 times row 2. -8 times row 2 and add it to row 3. Alright, and then I'll be replacing row 3. So I'm going to write 1 and 2 unchanged. So I have 1, -4, 3, 5, 0, 1, -2, -2. And now negative 8 times row 1 gives me negative 8 times row 2 gives me 0 plus 0. Negative 8 times 1 plus 8 gives me 0, which is why I did this. Negative 8 times negative 2 is 16 and a minus 10. And negative 8 times a negative 2 is a positive 16 plus a 4. And I don't remember having that. So is there a mistake? Up here, minus 2 times row 1. Yep, this was a minus way back here. Minus 2 times row 1 gives me minus 10 plus row 3 gives me a minus 4. Alright, so when I get to this one, negative 8 times negative 2 is positive 16. Minus a 4 is a 12. So hopefully you were seeing these mistakes and are so happy now that I've corrected them. Alright, we can finish and put this in total row echelon form by making this a 1. Divide everything in row 3. I'll write it like this. Row 3 divided by 6, replacing row 3. So I'll do 1 and 2 unchanged. 0, 0, 1, 2 when I do that. We are in complete row echelon form, so with that I can give you the answer to this. This will go back to equation land from matrix land. This is the x coefficient, this is the y coefficient, this is the z coefficient, and that's the constant. This is the y coefficient, this is the z coefficient, this is the constant. And lastly, this is the z coefficient, and this is the constant. So you can see we got z equals 2 right away, and we're just going to back substitute. So going back to this equation, we're going to put a 2 in for z. So we get y minus 4 equals minus 2, add a 4, and y equals 2. And we'll back substitute both of these values into the first equation there. So we get x minus 4. When I get to the y, I put in a 2, plus 3, z is 2 as well, equals 5. X minus 8 plus 6 equals 5. Minus 8 and plus 6 is a minus 2. So I'm going to move the 2 over and I get x equals 7. So the answer is, I'll go way back where I made an ordered triplet up here. We had a x equals 7, y equals 2, and z equals 2. That is the answer to our system of equations using matrices. So, just from that one example, I think that you will be able to do this tomorrow. So, sweet dreams and have a good night. Bye.